Bismillahirrahmanirrahim. The subject is electronic devices and circuit theory. Today our lecture number is 5. Lecture number is 4. We are studying the chapter number 5 of Boyle-Ested BJT AC analysis. So in the last lecture we discussed about the effect of source and load impedance on the gain of the amplifier. Today we first of all discuss the examples related to the previous lecture. Let's say we have amplifier in which RS and RL is connected. This is a two-port network in which we said earlier that there are three things are mentioned in the two-port system. That is the no load voltage gain. It is given as minus 480. We can see that this is minus, so maybe it might be the common emitter configuration. So we don't need to go into the depth of the type of configuration which this two-port system have. We are concerned with only the voltage gain, and it is given to us input impedance, and it is given to us, and the output impedance that is given to us. So now we have to study the effect of RS, source resistance, and the load resistance on the performance gain of this amplifier. So we have been asked to find out the AVL, that is loaded voltage gain, and after that we have to compare it with the no load value. No load voltage gain is 480, and after finding out the loaded voltage gain we have to compare both gains. Okay, then we have to repeat part A with the higher load value, load resistance value, and then we'll compare these results. And after that we will study the effect of RS. The source resistance is 0.2 kilo ohm, and in the last we have to find out the current gain, because we discussed in the last lecture that if you have the value of voltage gain, then you can determine the value of current gain from the voltage gain value. So first of all we have to find out the loaded voltage gain. The formula for the loaded voltage gain we studied earlier, that RL over RL plus R naught into no load voltage gain. So the no load voltage gain is minus 480, and load resistance value we have substituted over here, and R naught given in the uh, two port network package. This is R naught, which is 2 kilo ohm. So we have substituted R naught as 2 kilo ohm. RL was given to us load resistance, so the voltage gain comes equal to, this is loaded voltage gain, and you can see that no load voltage gain was 480 and the loaded voltage gain is 180. So it has been decreased from the no load value. So we have discussed earlier that your loaded voltage gain will always be less than the no load voltage gain. So you can see there is a comment by the author that it is a dramatic drop from the no load value. Similarly, in the second part we have been asked to repeat it with higher load value, with resistance of higher value. So second part only we have to replace RL with 5.6, the rest of the things are same, and you can see that this loaded voltage gain is less than the no load value, but it is reasonably close to the no load value. So it means that you have to you have to select your load resistance in such a way that it gives you maximum gain. Although this will always be less than the loaded voltage gain, will always be less than the no load value, but it depends largely on RL, its value, because if you used small value of RL, so it gain decreases too much, and if you use it with the RL value of higher value of RL, so it becomes very nearly equal to the no load voltage gain. Now in the C part we have to determine the effect of the source resistance. We have used the formula of a combined effect of RS and RL that we studied in the last lecture. So after substituting the value, we get the gain of minus 171, which is also less than the no load value. But you can see the sequence. We said in the last lecture that your no load voltage gain is highest among these three gains. Then comes the loaded voltage gain, and at the end, the overall voltage gain is less than among all the gains. And lastly, we have to determine the current gain, which is actually the ratio of I naught and I in, and we know I naught over ISB same ही होगा, and its formula from the voltage gain and current gain we have determined in the last lecture. So input impedance over RL. So input impedance can be found from this package. There is given Z in 4 kilo ohm, so we will use it as 4K over RL. RL is 5.6 kilo ohm. So voltage gain हमने we have substituted loaded voltage gain. So this is the current gain. So this was the example. Now we study the cascaded systems. Cascaded mean multiple stages of amplifiers are used and they are connected with each other. So there is a stage, multiple stages connected with each other. So the output of one amplifier is the input to the next amplifier. The overall voltage gain is determined by the product of the gains of the individual stages. So you have four stages in this diagram. So you will multiply the voltage gain AV1, AV2, AV3 and AVn up to n stages. It can be up to many stages. So DC biasing isolates these stages, but AC calculations and gains are dependent on each other. At the end, after the end, you can see their load is connected after the last stage and input is connected at the first stage. So it also the input impedance of this uh, the output impedance of gain stage 1 acts as an input impedance for the stage 2 and so on. The output of the stage 1 acts as an input to the stage 2 and so on. So the load resistance is connected at the last stage. So their gain get multiplied with each other. So overall gain becomes very high. So you can see the total gain is the multiplication of the stages of the gains. If there are a lot of stages, so they will be multiplied. The total voltage, total current gain will be calculated from the voltage gain by putting the input impedance of stage 1 and taking the load resistance of the output last stage. Now the example of this cascaded system, this is a two-stage amplifier in which one is the emitter follower configuration and other stage is the common base configuration. Input impedance, output impedances, and the no load voltage gains are given for each stage, and the load is connected at the outputs at the output of the last stage, and input is given to the first stage. This is RS and this is RL. So we have to find out very easy, very simple. Just individually you have to find out the gains of each stage, and then in order to find out the total gain, you will multiply these two gains. So first of all, we find AV1. So so in order to find out AV1, you just consider it V naught 1 over this over here. So V naught 1 will be Z into over Z into plus Z naught 1. We are here at this loop. We said earlier the ZO1, naught 1 and Z into. These will be connected in series, so there will be a voltage division at this output terminal. So in order to find out V naught 1, so we write the input impedance input impedance of this stage in the numerator divided by sum of these two, you can see over here, and multiplied by the input voltage, source voltage, because input voltage will be the input times the voltage gain. जब यहाँ पे voltage appear होगा आउटपुट पे, वो इसके voltage gain से मल्टीप्लाई होके इनपुट जो है इससे गेन टाइम्स मल्टीप्लाई होके आउटपुट पे आएगी. तो इसलिए हम इसको v टाइम्स a लिख रहे हैं यहाँ पे. अगर आप ये ना भी लिखें तो इसकी वैल्यू 1 हम गिवन है. सो v इनपुट, यहाँ से आपके पास वी आउट और वी इन के दरमियान एक रिलेशन आ जाएगा जिससे आप वोल्टेज गेन आप निकाल लेंगे. इसी तरह से जो अगली स्टेज है उसकी भी आप आउटपुट स्टेज पे जाएंगे, वहाँ पे वोल्टेज की रेशो लेंगे, उनको आप अरेंज करेंगे तो आपके पास सेकंड स्टेज का गेन आ जाएगा. फिर आप क्या करेंगे, फर्स्ट स्टेज और सेकंड स्टेज उन दोनों के गेन्स को आप यहाँ मल्टीप्लाई करेंगे तो आपके पास टोटल गेन आ जाएगा. जब आप इसको देखते हैं सेकंड स्टेज में आपके पास एक रेजिस्टेंस ये है और एक इसकी आउटपुट रेजिस्टेंस आ जाएगी जो कि थेवेनिन इम्पीडेंस होगी जो आउटपुट पर लगी होगी. तो जो थेवेनिन इम्पीडेंस होगी that will be in series with this RL, and you have to find out V naught which is across this RL, and RL is in series with Z naught. तो यहाँ पे भी वोल्टेज डिवीजन रूल लगाएंगे और इसका जो सोर्स वोल्टेज होगा, इनपुट वोल्टेज, वो इस गेन टाइम्स द इनपुट स्टेज ऑफ सेकंड पे जो इनपुट आ रही है वो होगी. सो इनपुट ऑफ सेकंड स्टेज मल्टीप्लाइड बाय द नो लोड वोल्टेज गेन ऑफ सेकंड स्टेज, और ये आपकी आउटपुट साइड के ऊपर जो VDR आपने लगाया है. सो इससे आपको क्या मिलेगा, V02 which is over here, this there is V02 which is across RL. So after substituting values and you find total gain, this is the overall gain. We said total gain input impedance over the sum of RS plus Rin, the overall current gain. Similarly, you can find the rest of the values because we discussed in the last lecture V in over IS, V naught over V in. If you product these two, so you can find overall gain. Now this is the last topic of the chapter number 5, RC coupled BJT amplifier. This is also the kind of cascaded amplifier. You can see the first stage is the voltage divider configuration, and other is also a voltage divider configuration, and both these two are coupled with a capacitor. So this is the RC coupled BJT amplifiers. So you can see the voltage gain of stage 1 will be the resistances of the output of stage 1 in parallel with the इनपुट इम्पिडेंसेस ऑफ स्टेज 2, बिकॉज स्टेज 2 जो है उसकी भी जो इनपुट इम्पिडेंसेस हैं वो अब स्टेज 1 की आउटपुट इम्पिडेंसेस के साथ कनेक्टेड हैं. तो वो अब आपकी आउटपुट के तौर पे अपीयर होंगी ओवरऑल RE. तो ये आपके पास स्टेज 1 का गेन आ गया. फिर इस तरह स्टेज 2 में आपके पास आउटपुट इम्पिडेंस जो है वो RC है और इनपुट इम्पिडेंस स्मॉल r, दोनों के गेन्स आपस में प्रोडक्ट लेकर ओवरऑल गेन आपको मिल जाएगा.